everyone. This is a lecture review for our chapter on memory for Psych 200. So the first thing, to get us thinking about memory, what I'd ask you to do is think in your brain about everything you did today and just try to list that out. So you can pause the video and just, think from the minute you woke up until now, what did you do? I'll give you a minute. Okay. Let's say you're done now. So what I'd like for you to do is circle all the activities then that do not require any form of memory to complete at all. So everything you did today that you did not need to remember something in order to accomplish, please circle that. Any luck? If you're like most of us, you are probably not writing things that don't require any memory. So, if you went to school, then you figured out how to get there. You remembered what a school was. You remembered where your car was. How do you drive a car? If you got dressed, you remember where clothing goes, where your clothing is, the clothes you're supposed to wear, how you put them on. You probably didn't come in with underwear on your head. You have to remember certain things. And you probably managed to make that work if you're here today. Some of the things that we do that really don't require memory are just really the basic functions like breathing, waking up, keeping our posture, just very, very simple things. So if we didn't have any memory at all and we were relegated to the things that we can do without memory, we would have very boring lives, pretty reminiscent of like a rock or something. Be pretty boring. So thankfully we have memory. So what memory does, then it helps us to process information. And there's lots of information that we get from our environment. So many memory models really compare this memory process to a computer. And it's this set of processes that we use to encode, store, and retrieve. And so we'll talk about these three functions. Encoding, we're getting the information in. Storing it, we have to retain it somehow, and then retrieval, we need to pull it back into our awareness when we need it. So encoding, some things we encode automatically. So things like time and space, frequency, we don't have to spend a lot of time thinking about those things. They're pretty automatic. Other things are going to take a while for us to really learn. So if you take algebra, or statistics, you're probably going to take some time to have to remember those formulas and what goes here, what goes there. It requires effort. It's not something that's immediately remembered. So it takes you a while to do that. The meaning of words makes a big difference in whether or not we can remember them. So if you read these three sentences really quick, think about whether or not these make sense. And then try and remember these. So if you were to read these three right now, the notes were sour because the scene is split. And then just keep reading. And then take a break, maybe pause me again, I'll wait for you. And try and recall the sentences that are here. So read through them, take a break, maybe 30 seconds or a minute, and then try to recall them. Any luck? So these sentences don't make any sense for the most part. If you put them in context, though, so now we've got bagpipe, ship christening, and parachutist, each of these sentences now makes sense, and it's going to be so much easier to remember them. So the first sentence, the notes were sour because the seam split. If you think about a bagpipe, that makes sense. The bagpipe fell apart, and the notes didn't sound good. The voyage wasn't delayed, the bottle shattered, so they christened the ship with the bottle, it shattered, off the voyage went. And then the haystack was important because the cloth ripped. If you're relying on a parachute that rips and you land in a haystack, hey, you survived, so it's very important. So if you put sentences into, having a purpose, if they're meaningful, so much easier to remember them. A couple types of encoding that we have. Semantic encoding is words, visual encoding is images, and then acoustic encoding is sounds. For a lot of us, this means that we can record things and remember things really well when they are in sounds. So we often use sounds to teach children. ABCs is using sounds, so it helps them to remember, to encode our alphabet. Some words that are really high imagery, like cat, you'll incorporate that, not only the word, but also the visual image of a cat. We also know that from our memory that we encode something much better if we can make it self-relevant. So if you can, try and encode something about bagpipes, and you think about that time you went to your cousin's wedding and they had that strange bagpipist there who was playing all these notes you've never heard before. If you can incorporate it that way by remembering your own life, you're going to keep it much better than someone who can't encode like that. Once we've got it encoded, we have to store it, so it's got to go somewhere. So this AS model is one that's often mentioned with memory storage. So what this says is that we have sensory input, which is right now for you, my voice, the video, anything you're bringing in for your senses. This is very short memory, so you have to kind of pay attention to this in order to bring it into short-term memory. So this sensory memory, if you don't kind of pay attention, it just goes away. Bye. But if you do pay attention, that's when you get it into short-term memory. So hopefully you're bringing my voice in, you're paying attention, and it's in your short-term memory. So from there, you would rehearse it, think about it, bring it in with information you already know, and then hopefully transfer that into your long-term memory storage so you can pull it up later in life. Badley and Hitch also had a really popular model for short-term memory itself, and they said we have a phonological loop, visuospatial sketchpad, and an episodic buffer. So it said these are three components of short-term memory that are then kind of organized by this central executive. The loop is for language, the sketchpad is for more visual information, and the episodic buffer is more for parts of your own life. And all of this kind of comes together for short-term memory and is organized by that executive figure. Sensory memory is something that is really interesting. So sensory memory, we've talked about this just a minute ago, but it's bringing that stuff in. Sights, sounds, taste, very quick. If you don't pay attention, it's gone. So if it's valuable, you'll bring it into short-term memory. The Stroop effect kind of plays on this idea of sensory memory. So what we're supposed to actually do with these, the Stroop effect is to read the word and not the color. So sometimes you'll do it the other way, say the color and don't read the word. But this is a really difficult thing to do. So for that first block, if we were saying the words, we'd want to say red. But of course it's printed in blue, and so our mind has to kind of make that switch. So the next one I'd say blue, then yellow, orange, purple, orange, green, yellow, black. But then if we switch the rule, we'd have to now say the color it's in. Blue, orange, red, orange, yellow, purple, and it can be quite challenging. So you can try and have fun with the Stroop effect. For short-term memory, we call this working memory. And for this, it lasts about 20 seconds, and the capacity seems to be about 7 items, plus or minus 2. So somewhere between 5 and 9 items. So in order to test your own short-term memory, you can print out the slide here, you can give one of your friends those numbers at the bottom, have them read them out loud to you, give you a short break, and then you try and recall those to see how many you can actually bring together. And then long-term memory is our continuous and unlimited storage of information. So a lot of times people will think long-term memory is more like decades, years ago. But actually, if you can remember something that happened today, several minutes or hours ago, then we think that's in long-term memory. So what you ate for lunch, even though you won't retain it for 20 years, probably, unless it was super exciting. But for me, it was this bagel here, so I'm not going to remember this bagel that I eat 20 years from now. But if I remember it 2 hours from now, it's in long-term memory. So some memories, though, can only be recalled through prompts. And so if you were trying to help me remember my bagel, then you might say things like Panera bread, sesame seed, cream cheese, these kind of prompts to help me remember what was it that I ate. Long-term memory, we can also kind of divide this into different portions. So the explicit are things you can kind of say, they're declarative. And implicit are things that you can't really say, it's more of things you can kind of do. So for our declarative, we have the episodic, which are things you've experienced, and the semantic, which is more kind of public, basic knowledge, like who was the first president. That is semantic knowledge. For the implicit, we have procedural knowledge, and that's how to do things. So you might not have ridden a bike for 10 years, but you get back on it and you can ride it. That's your procedural memory. And then emotional conditioning is more of these emotional aspects of learning, conditioning. So this is what's kind of happening in our long-term memory storage. Superior autobiographical memory is something we're just starting to really learn about. So we've only been able to identify, or scientists have only been able to identify, about 20 people who have this ability, but really it seems like they can remember their entire lives. So you could ask them what happened June 1st, 1999, and they could seem to scroll back in their memory and actually report on what happened at that time. So it's a really fascinating thing. It's going to hopefully show us a lot about how memory works and the functions of memory. So I would encourage you to watch the videos linked below called Endless Memory through CBS. You can also find them on YouTube. But really, really fascinating stuff. So retrieval, for many of us, retrieval is not going to be our entire life like these individuals we talked about here with the superior autobiographical memory. For us, retrieval is going to be more ways that we can kind of pull things into our consciousness. So we're getting memory back out of memory storage, back into conscious awareness. So we can do this by recall, and so that's if we don't have any cues and we can just pull it up. So for recall, we often think of this maybe as like an essay test. There's no cues, you just pull it out of your brain. Recognition is being able to recognize and identify information that you've learned. So this is more of a multiple choice test. If you see a list of concepts, do you recognize certain concepts? And then relearning is learning something again after you've learned it. So maybe you haven't spoken Spanish in 20 years since you left Spain, and then you go pick it back up right away as soon as you enter your Spanish class in college. So that would be relearning. You're able to pick it back up much more quickly than someone who's never learned it in the first place. Memory in the brain. So this is a really interesting topic. A scientist named Lashley, he actually had rats, and he was searching for the engram, which is supposed to be this physical representation of memory. So what he was interested in is if he taught rats how to maneuver a maze, then kind of you pretty much use a soldering iron to remove portions of their brain. If he could actually find that memory and take it out, and then prevent them from understanding how to run the maze again. But, he did this over and over and over and over, and he was never able to erase that engram, so they could still navigate the maze. And so what this tells us then is that memory is kind of distributed throughout the brain. But there are some important brain regions for memory that you should know. Amygdala is important, especially for emotional memories. The hippocampus is something that we talked about when we discussed the HM case earlier in the semester, but this is something that's really needed for declarative, episodic memory. The cerebellum helps with procedural memories, the prefrontal cortex with some of our semantic word knowledge type tasks. And then we've got some neurotransmitters implicated as well. So the kind of important thing about memory in the brain is that it's throughout the brain. Many different portions are important. Many different functions kind of have to take place before we can remember something, encode it, store it, retrieve it. Some memories that we have that many of us really remember strongly are called flashbulb memories. So these are often really cemented by strong emotion. So if you have a brand new newborn baby, that's a lot of strong emotion, and it can help to kind of form that memory into a strong memory. For many of us, if you were 8 or older during 9/11, then many of us have encoded the terrorist attack on 9/11 as a flashbulb memory. So people can report exactly what they were doing when they heard that this had happened. So what they were wearing, seeing, who they were with. Many of us feel like we can just bring that right back up to memory. But even these flashbulb memories can have decreased accuracy. So even though it was so salient, these memories can still decay just like other memories. So other forms of long-term memory, or other issues we can have with long-term memory, is one thing is amnesia. So with amnesia, we've got anterior grade versus retrograde. Anterior grade amnesia, this is when you can't remember anything new. So you had some kind of trauma occur, some kind of situation, maybe a car accident, and then you can't remember new information. With retrograde, it's the opposite. So you can't remember things that happened before your accident or your trauma. So you can watch this video of Scott Baldwin, who is a football player, and he kind of lost 46 years in a minute is what after he fell. And so he's got this retrograde amnesia. So memory, every time we pull our memories back up, we construct them and when we form them, and then we reconstruct them when we bring them back up. So memory is flexible. With this reconstructive process, you can have a lot of things kind of come into play. Suggestibility, you can have something from an external source that you're not even aware is really entering your mind, and it can lead to this creation of false memories. It can alter that initial memory. So one really, really important application of understanding this flexibility and fragility of memory is with looking at eyewitness testimony. So I would really encourage you to watch these videos linked here. I think if you don't watch any videos, these ones, those are the ones I'd pick. It's from Jennifer Thompson and Ronald Cotton, and the book is called Picking Cotton that they wrote about, but it's about a woman who experienced a sexual assault and used her own eyewitness testimony to identify her perpetrator, but she identified the wrong man. And if you watch through, you'll see how this happens. There's many ways that witnesses can be accidentally misled, which is what happened in that case. One big researcher in this area is Loftus, and she showed us this misinformation effect and how easily this can occur. So she had people watch video footage of a car accident, and then after they watched it, she asked them certain questions. So one group heard then how fast were the cars going when they smashed. Another group heard how fast were they going when they collided. Then we've got another group that heard bumped, hit, contacted. So the people who heard things like smashed actually rated these cars as going faster than the people who heard things like contacted. So how fast were the cars going when they contacted? Not very fast. How fast were they going when they smashed? Oh, so fast. So it was a statistically significant difference there between those verbs. So even though they watched the exact same video, the question led them to identify a different answer. So another big thing that happens with our memory is that we can forget. Everyone has forgot something, so you just can't bring that information back up from long-term memory. And there are several reasons why this could be. A big one is encoding failure, so you just never bother to really try to remember it. So for many of us, if you look at these coins here, you wouldn't be able to identify which one it actually is because you've never spent time actually staring at the coins. If I remember right, I think it's C. It says so in your book, but I think it was C. But yeah, I've never spent the time to encode these. I don't immediately know that one. So we just never spend enough time. So you got to stare at money to make sure you know. There's also a lot of memory errors that we can make. So this will go through each of these sins or memory errors. But we have things like transient. So that's just you forget things that happened a long time ago. Absent-mindedness. We all have had that where you're like, where did I leave my computer? I don't know, it's gone. And then you just kind of forget because you're not paying attention. Blocking, so that can be that feeling something's on the tip of your tongue and you just can't remember it. You're like, oh, it's right there, and then you pick out your phone and Google it now, but it's it's a bad feeling. You're like, oh, it's so close. Misattribution is when your source of memory is confused. So if you've ever had a dream where your partner cheats on you and you wake up and you're like, how dare you? I'll get you, buddy. Then you've misattributed the real world as a dream. Suggestibility we've talked about already, so that with the misinformation effect and with with kind of leading questions. Bias is something that occurs with all of us, so we can align our memories to our current beliefs. So maybe you thought your relationship partner was great, but then he or she dumps you in a really harsh manner, and now all of your memories kind of become distorted by the fact that that person was a jerk. And then persistence is when we just can't forget something that we actually do want to forget. So it's pretty good to forget, the time you fell on your butt in front of your whole high school and dropped food all over your face. Most of us, we don't want to relive that. That was horrible. And so it's nice to be able to forget things sometimes. Ebbinghaus was someone who did research on himself. He had himself memorize all of these syllables that were just nonsense. And then he kind of then measured how much he retained. And he came up with this now famous forgetting curve. So what we can see is that he memorized these syllables like L-O-W, L-Q-Z, just random junk, and he memorized these lists. And really within 20 minutes, he forgot a big chunk of it. And then, the forgetting kind of happened for a little while over, the next 40 minutes or so up to about 60 minutes. And then, we've got a little bit of loss after that time, but it's really seeming to kind of steady out. And so it seems like we forget a lot of what we've learned right away, but some of it will stay with us. And some of that knowledge we'll keep then, for several days. We can have knowledge, though, that becomes, that has interference, experiences interference. So proactive interference is when you've got old information, like an old high school locker convo, that messes with new information. And the retroactive interference is the opposite. So you've got new information that now makes it where you can't remember old stuff. So, I've had many addresses moving around for college and for grad school, and my new address has kind of messed up all of my old info. I can't remember where I used to live. And so I'll fill out forms and be like, all I remember is my new address. So I've experienced in this retroactive interference, my new address has hindered the recall of my old addresses. So you probably experienced both of these forms of interference before. So that what can we learn about the science of memory then to help us enhance our memory? That should be kind of the point, right? So we can remember things better, stronger. So there's some strategies like rehearsal. This is kind of if you want to remember the number to dominoes and you keep saying in your head like, 6689, 6689, 6689, and you're going to call dominoes. I don't know if that's really dominoes number, but for the sake of the argument, you're going to call dominoes. But the problem with that is if anybody interrupts you in some way, it's gone. Like, I don't even remember what the number was, and I just finished saying it. So it's gone. So that's probably not the best strategy. So some other good ways to organize information is things like chunking. So if you've got a long string of numbers, chunk it. That's why this is done to phone numbers, to credit card numbers, social security numbers. That's why they're chunked, so you can remember them. Elaborative rehearsal is bringing it in, remembering it, putting it in context of things you already know. So if you're trying to remember a phone number, you might think, oh, it's my dad's birthday plus the day I got my dog plus 24. You try to remember it by chunking and using elaborative rehearsal to bring it in to things you already know. And then using mnemonic devices, like we see the knuckles here, so it's some kind of memory aid to help us remember, or like please excuse my dear Aunt Sally is one that we often use. And then writing it, saying it out loud can help. So to study effectively, you can use this information to help you really, be a champion studier. So use that elaborative rehearsal, make it more about yourself, apply that self-reference effect. Don't forget the forgetting curve. So we do lose quite a bit of information that we first study and retain. So you need to rehearse and rehearse and rehearse to kind of overcome that loss. Be aware of the interference that you can experience. And then some just general things. Keep moving, get enough sleep. So really our research in psychology has supported both of these activities, physical activity and sleep, as important for your memory. And then make use of mnemonics. But that's the chapter for memory. So thank you very much and have a wonderful day. And